And I know that a couple of people put in the chat that they already knew that the answer was going to be 1 minus 4x. I want to write a couple more examples here. So I've got f of x. Let's say that I had, how about 3x squared plus 6x to the 4th. And if you think you know the answer to this, go ahead and type it in the chat right now. Have a feeling at least somebody has an idea of what the answer is going to be here. Okay, nice. I also love that everybody is learning to type math into the chat. Fun fact, if you want to write x squared, you can type x and then hold the Alt key and keep it pressed down while you type in 0, 1, 7, 8. If you want to write x cubed, type x, and then when you're done typing the 8, you can just let go, and it'll put in the 2 for you. And Alt 0, 1, 7, 9 should give you a something cubed. So just in case you want to type more math in squared and cubed, I know the alt codes for. I don't know the alt codes for anything else, but I know a few others, but these are two that I use a lot. So I talked for a little bit to stall enough time so that we got 6x plus 24x cubed. I am wondering if anyone is willing to, and I'll ask you to raise your hand just in case there are a lot of people that want to do it, but would anybody be willing to walk us through how they would figure out the derivative if I gave you 5x to the 10th minus 2x cubed plus 8x? So I'm looking for a volunteer. So you can raise your hand in that participants window. You can volunteer by typing in the chat, hey, I want to do it. It does not have to be a mathy explanation. Thank you, Haley. Okay, go for it. Oh, nice question. Do you get extra credit for the pass, no pass class? Sure, yeah.
So in order to do this, there are like certain rules for when you're finding derivatives, and one of them, I think it's called the coefficient rule, which says that like if you have a coefficient, you can just like take it out, and so when you find the derivative, it's like you have a coefficient of that one, you can just multiply it by the coefficient. And the second one you're going to use is called the power rule, which states that if you have x to the n, the derivative of that is equal to n times x to the n minus 1. And so if you're using the coefficient rule here for the first term, and like the other rule is that you can, if you have a bunch of different terms, you can find the derivative of each one of them, and then you can like add or subtract them together. And so for the first term, you could take the coefficient away and you could find the derivative of x to the 10th. So it'd be 10x to the 9th times 5. And then for the second one, you could like take the -2 out and then find the derivative of x to the 3rd. So that'd be 3x squared. And then for the last one, since it's like only x to the 1, you could take the 8 out and then do like 1x to the 0, but that would just be 1 times 1, which would just be 1. So it'd just be 8. And so there would be no thing, and then you would just like simplify that.
Sweet. Everybody get ready to type a number in the chat. If I told you that I have a line, y equals 2x minus 5, what's the slope of that line? Go. Sweet. Oh, we should have made this a race. Like, who could type it the fastest? Absolutely. The slope of this line is 2. Well, what does the derivative mean anyway? the derivative means the slope. It's the slope of the tangent line. But if my function is already a line, then it means the slope. So I know that anytime I have a linear function, I already know what that derivative is going to be because we can just steal the slope. Now, in a similar way, I'm going to write another equation of a line. Get ready. You're going to tell me the slope. What is the slope of x equals 5? I tricked everybody, but it's okay. So x equals 5, I know this always feels backwards, but if I go to graph x equals 5, that's where x equals 5 is, which means this is actually a vertical line. So we say that it's an undefined slope or an infinite slope. So that one was kind of a trick question. I think what everybody was trying to answer is if I had asked you, what if y is equal to 5? So if y is equal to 5, here's y is equal to 5. So that line would be up here, and that is a slope of 0. So we can do fancy things, and I think Haley even talked through it of what we could do with that 8x and think about that as 8x to the 1 and bring it down and then x to the 0. I really prefer to use the skills we've already got. So if I had a function that was 3x to the 5th plus 2x plus 5, I have this linear piece out here. If I asked you to find the derivative, then this piece out here, that's a line, and we already know what the slope of this line is. It's 2. Now the derivative of 3x to the 5th, if we kind of combine that coefficient rule with the power rule, then I'm going to say, I'm going to take the current exponent and multiply it down in front so that I'd have 3 times 5 and then subtract 1 from the exponent. So I had an exponent of 5, I'm going to subtract 1 and get 4. And then we can simplify that if we want to say 15x to the 4th plus 2. Let's say that I had some kind of graph here and it looks like this. And so a couple of things that we might be asked, if this is representing a position or a distance, and this is representing a time, then when we think about the slope on this graph as being a change in y over a change in x, we'd be looking at a change in the distance divided by a change in the time. And sometimes people remember this as dirt, that distance equals rate times time. Well, that means this rate is equal to a distance over time, and that change in distance over change in time is the rate that we're moving at. And one of the words we use for that rate that we're moving at is velocity. So this change in distance over change in time, this is some kind of velocity. And in particular, we talk about an average rate of change or an average velocity and an instantaneous rate of change. So let's get an actual function up here, not my random picture. And so my function s of t is going to be, let's go with 10 minus 2t squared. Cubed. 10 minus 2t cubed. I lied. 10 minus 2t cubed. So this is my function that's going to tell me my position after t minutes. So maybe that S is in feet and my t is in minutes. And I'm just going to specify minutes. And I'm going to specify that up at the beginning. And I want to know in the first 2 minutes, how far, nope. In the first 2 minutes, what was the average velocity? Now that phrase average velocity, we can interchange that with a couple of things. So average velocity, I can think about as the change in distance over the change in time. I might also refer to this as the slope of the secant. Or I might call this, especially if I'm Kuba, I'm going to call this AROC, or the average rate of change. What I actually like to think about average velocity as old school slope. Change in y over change in x. Now my y has a different name right now. My y is currently called s of t, and my x has a different name right now. My x is currently called t, but we're looking for old school slope when we're looking for average velocity. So now we need to decode the rest of this part. In the first 2 minutes. In general, if it's not specified, we're starting our clock at 0. So that question of in the first 2 minutes, what is the average velocity, secretly means from t equals 0 to t equals 2. That's what that first 2 minutes is telling me. Now, if I'm going to find old school slope or slope of a secant line or average rate of change or change in distance over change in time, that means I need to know where am I when t equals 0 and where am I when t equals 2. Well, when t equals 0, s of 0 is 10, plugging in 0 here for t. And when t equals 2, oh, we already know the t part. When t equals 2, s of 2, 2 squared is 8. 8 times 2 is 16. 10 minus 16 is -6. This means that I can find the average rate of change or the average velocity. And I'm looking for the change in s over the change in time, or final minus initial. So -6 minus 10 over 2 minus 0. So it looks to me like I get -16 over 2, or -8. A couple of things. When we're talking about velocity, in general, when we're talking about rates of change, if we've been given units in the problem, we want to make sure to report out our answer with units. So I'm going to come back and look at, well, s was in feet and t was in minutes. So this is going to be a -8 feet per minute. For this same question, if I change, or for this same situation, if I were to change from an average velocity to wanting to know the instantaneous velocity, then we're changing from the slope of a secant to the slope of a tangent line. So for average velocity, I'm looking at 2 points. We're talking old school slope. For velocity or instantaneous velocity, I want the calculus-y version of a slope, meaning the slope at a single point. let's think about what those two are going to look like graphically. So 10 minus 2t cubed. Man, I got my work cut out for me. I picked a cubic. It looks like my cubic is shifted up 10. And because of that minus sign, I know it's not going to be one of these. It's going to be one of those. So whatever else is happening on this picture, it's shifted up 10. And it's going to look something like this. Well, we know 2 points that we can anchor it with. Here's my S, here's my T, because we've already found 2 of these points. So I know that right here, that's the point 0, 10. And I know that after 2 seconds, I'm at -6. So I'm not sure exactly where that is to scale, but let's just say that's right here. That's 2, -6. So when we find that average rate of change, we're connecting the dots and finding the slope of the line that runs right there. Okay, I got a little bit wiggly, but the slope of that line would be -8. If I asked for the instantaneous rate of change or the instantaneous velocity, then rather than specifying 2 points, I'm going to specify 1 point and say, where is the 1 point that I care about the instantaneous velocity at? So if my picture is decent at all, if I look for the instantaneous velocity at x equals 2, I expect to have a steeper slope. And the reason I say that is that if I look on my picture and I try to just draw in the tangent line right there, then that tangent line still has a negative slope, but it's more steep. So let's see what happens if we, instead of finding the average rate of the average velocity, let's come in and say, instead of in the first 2 minutes, we want to say after 2 minutes, what was the instantaneous velocity? And that instantaneous velocity is asking us to take the derivative. So right now we've got s of t is equal to 10 minus 2t cubed. And I need to find s prime. And specifically, I'm going to need s prime of 2 to answer the question. Well, if we go to take the derivative here, and I think about this as 2 separate pieces, if I think about the 10, what would the slope of a line be that said y equals 10? Well, that slope would be 0. So in general, the derivative of any constant is going to be 0. Now I'm going to use our coefficient and power rules over here. So I'll take that 3, multiply it by the coefficient of -2. So I'll get -6. And then we're going to subtract 1 from the exponent and get a 2. So if I check that instantaneous velocity after 2 minutes, that's going to look like -6 times 2 squared, which I think is -24. So my graph isn't too far off, right? I was expecting to get a steeper slope based on that graph. Now we should come back and worry about units for a minute. There's a subtlety in our notation that, or like some new notation that we haven't talked about yet, but s prime of 2 or that s prime of t, when we have the average rate of change, we might write that as delta s over delta t. And what we do when we're turning that into an instantaneous rate of change, or if we're talking about the derivative, we change those deltas to be a d. So I'd have ds dt. Oh, units wise, I'm going to keep those same units, whether it's the average velocity or the instantaneous velocity. I need the units for s, which in this case are feet, divided by the units for t, which in this case are minutes.